In this review video, we are going to be looking at factoring. So remember, the first type of factoring that we always talk about is looking to see if there's a greatest common factor. And a greatest common factor can be a number, a variable, or a combination of number and variable. So looking at this binomial, I can see that my coefficients are 4 and 16. So the GCF there is going to be 4. I can look at my variables. I see that there is an x squared and an x. And so that is going to tell me the GCF between those two is an x. And then if I look at the y's, I have a y and a y squared. And so the GCF is going to be a y. So remember, we always write our greatest common factor on the outside of our parenthesis. And then we look at these two individual problems. So here's our first one. Our 4's are going to cancel out. X squared over x will leave us 1x. Our y's will cancel out. When we go to our next problem here, I'm going to take negative 16 divided by 4. That is going to give us a negative 4. Our x's will cancel out. Y squared over y will leave us y to the first. Remember that we always want to look inside the parentheses and see if we can factor any further. If I look inside here, I see a binomial. I know the only other pattern I know for a binomial is a difference of 2 squares, which meets the pattern perfect square minus perfect square. Since that is not present in this problem, this is our answer. All right, our next one. Remember, if we think about the flow chart that we did in class, always think, is there a greatest common factor? There is not one in this problem. And then I look at the number of terms. There are 2 terms. And I know that the only pattern I know for 2 terms is perfect square minus perfect square, which this does fit. So the 4x squared is 2x and 2x. And then the negative 25 comes from a plus 5 times a negative 5. And there is our answer for that problem. Okay, our next one is x squared minus x minus 20. So we look at always a GCF. This one does not have one. And then I look at the number of terms. I have 3 terms. And when I have 3 terms, the next thing I look at is for what the a value is. And the a value happens to be 1 here. So I'm going to organize my thoughts by using that x. So I'm looking for 2 numbers that multiply to a negative 20 that add to a negative 1. And so if they're multiplying to a negative 20, we need one to be positive, one to be negative. And we need them to add to a negative 1, so that's going to be a negative 5 and a positive 4. And then my factors must be x plus 5 and x minus 1. Neither of those factors can be factored any further, and so then that is my answer. All right, my next one, I look to see first, is there a greatest common factor? There is not between 16, 24, and 9. So then I am going to look and see that this is a trinomial. And this one is a trinomial where a doesn't equal 1. And I have 2 things. I can actually just go to trial and error right now, or I can look to see if this is a perfect square trinomial, and that works. I do notice that we have a perfect square here and a perfect square here, so I am going to try that. So 4x and 4x would give me the 16x squared. 9 would be 3 and 3. This being positive tells me that my parentheses are either going to be 2 positive signs or 2 negative signs. If I look over here, that tells me it's going to be 2 positive. Remember, I always want to check with the perfect square to see if this middle term works out correctly. And if I multiply here, that gives me a positive 12x. And if I multiply here, that's a positive 12x. Add those together would give me 24x, which is what we were looking for as our middle term. So then this is the correct factorization. And remember that you can also write that, since a perfect square trinomial, in this manner also. All right, our next problem here is look for a GCF. 2, 7, and 3, there's no GCF. I see a trinomial. I look at the A value doesn't equal 1. And looking at this, I don't see a perfect square either here or here, so I know I'm going to rule out that perfect square trinomial, and I'm going to have to look at A equal 1, which is trial and error. So what do I know? I know that 2x squared can only be 2x times x. I know that if this is a positive, my factors are either both going to be positives or they're both going to be negatives. I look here to find out they're both going to be positive. And now I just have to look at this 3 and arrange the 3 times 1 so that I can get a 7x in the middle. If I put a 3 here and a 1 there, I'm going to check. This will be a 1x. If I multiply this, this will be a 6x. 1x and 6x will be 7x, which is the middle term that we wanted. And so this is the correct set of factors. All right, so as always, I look to see, is there a greatest common factor? I have 4 terms this time. There's not a number or a variable in common to all 4 terms, so I'm going to take and cross that out. Since there are 4 terms, I know that this is going to be a grouping problem. So I'm going to take and group this into 2 parts. I'm going to look at my first part here and look for the GCF. The GCF between x to the third and 2x squared is going to be just an x squared. And I'm going to take and divide that out of each one of these problems. And so this will be x to the third over x to the second will be x. Here, those will cancel out and leave me with a plus 2. When I go to look at my other group over here, I see that this is a minus sign, so I immediately know my GCF is going to be negative. And that it's going to be, when I look at 3 and 6, my GCF is going to be a 3. So negative 3 coming out of both of those, that is going to leave me with an x and a plus 2. So remember, if I've done this correctly, this and this should match, and that becomes one of my factors. My other factor I create from the greatest common factor of the first group and the greatest common factor of the second group. Remember that all of these factoring problems, that you can check your answer by multiplying, either using distributive property or box method, and it would get you back to the original problem.